guys and girls, today we're looking at expanding binomial products. And what that means for us is that we're going to take these brackets and times them by each other and get their answer. Okay, so let's get started. With this, the key thing is that when stuff is in brackets and there's two brackets, you have to times everything in the first bracket by everything in the second bracket. Okay, so the x needs to be times by both the first x and then the 7, and then the 3 from the first bracket needs to be times by the x from the second bracket and the 7. So you can see that there's a line going from every part of the first bracket to every part of the second bracket. And what you do is you just times following those lines. So for each of these, I'd actually draw those lines and then times following them. Okay? So we start off with the x times x, the first number times the first number. Okay? That first line. Okay? And then x times 7 plus 7x. 7x's 7x. Then plus 3x. Okay, and then 3 to 7, 21. Okay, now hopefully you'll see that I've got 7x and 3x in the middle, so I can simplify it by just going x squared, because that doesn't go with anything, and then 10x, the 7x and the 3x, plus 21. Okay, and that's my final answer. All of this stuff, the x plus 3, in brackets, 7 plus x in brackets, times together gives me x squared plus 10x plus 21. Okay, let's give the next one a crack. My first job, I might give myself a little bit more space actually. Sorry about that. My first job is to draw the lines just like before. So from 3x to both terms in the upper brackets, and from 1 to both terms in the upper brackets. Now here I've got a number in front of the x, which is 3. So I go 3x times x, which gives me 3x squared. Then I've got 3x times 9, which gives me 27x. Then I've got 1 times x, which gives me x. I've got 1 times 9, which gives me 9. Okay? Oh, I might move this to the other side actually, give myself some even more space. Okay, so now I do exactly the same thing. The 3x squared doesn't go like with any of the others, but I've got 27x and x, which are like terms. So I go 3x squared plus 28x plus 9. Okay, and that's the expansion of that one. Now finally, I've got this x plus 9 squared. Okay, and this may not look like the others, but actually it is. X plus 9 is squared. Everything in the brackets is times by itself. So we can write it as two brackets exactly the same. X plus 9. X plus 9. And then draw the arrows. Okay, and then do the times. So x squared plus 9x plus 81. Okay, and that's that style of fig. It's exactly like the others. It doesn't look like that question, but it is, because when you're squaring, you're timesing it by itself. You're taking one bracket and timesing it by the same bracket. Okay, now that's the examples I'm going to do. If you want to sort of crack on and just do them as best you can, that's awesome. What I'll do for the rest of the video is just go through a different way of doing it, this foil way, which I don't like as well, but some people do. And I'll also do a little bit of an explanation of the maths behind why this works. But if you're keen to just get started, go on with the problems. Okay, so for people interested in the y, I'll explain a little bit of the y and foil at the same time. Okay, I think when we're learning our 12 times tables, this is the best example of this. If you've got 12, it's made up of 10 and 2. Okay, so 12 times 13, say, is made up of 10 plus 2 and 10 plus 3. And this is the way many people do this times table in their head. You might have done this sort of thing before and just not sort of thought about it. Okay, so 10 times 10 is my first part. Okay, and I'll use this to explain the FOIL thing. The acronym FOIL says first times first, so it's that first line, 10 times 10. And that gives me 100. That's exactly like squaring the x's in the first example. Okay, then I go outside times outside. So the outside 10 times the outside 3, which is 30. The inside 2 times the inside 10. This is just following the lines like before, or using this FOIL acronym. First, outside, inside, last. Did the first ones, did the outside. Now I'm up to the inside, which is 2 times 10, 20. And then the last 2 times 3, 6. Okay, so I did the first, outside, inside, and last, and I ended up with 156, which, if you'd like to check on your calculator, is 12 times 13. Now, this is a universal pattern of number. We can always sort of times like this, and it'll work, because to times a number plus another number, a number plus another number, we just times each part of this one by each part of the second one. Okay, so that was a little bit of FOIL. I personally don't like this one, but a lot of people do, so I'm more than happy to take you through it again if you think that might be better for you. And that's a little bit of why it works, because it'll work with all numbers, it'll work with the algebra as well. And that was expanding binomial products. Bye, guys and girls.